in this video, we're going to take a look at what are called the laws of logarithms, okay? And before we do that, I just want to remind you of your power or exponent laws from back in grade 9. Okay, so hopefully you remember these. They were in the review as well, but the first one is our product law or our multiplication law. So when we are multiplying two powers that have the same base, we simply keep the base and we add the exponents. Okay, similarly, we had a quotient law or a division law, if you like. So when we are dividing powers that have the same base, we can simply keep the base, subtract the exponents. Okay, and the last one was called the power law or power of a power law, if you like. And that would be if we had a power to another power, right? And hopefully you remember that this one was you multiply the powers together. So I'm just putting them right beside each other so you can see that they're multiplied. You could put a dot in there. So similarly, there are three laws that we use for simplifying logarithms. So in this first one, you'll see that we're adding two logarithms together that do have the same base. I've called it a here, but they have the same base. And so that simplifies to a single log, which is log with that same base, where we can multiply m times n together. Okay, and this one is called the product law of logarithms. So let's try just a couple of examples together. So here, and you see in the first example, we're adding two logarithms. So we can write them as a single logarithm. So it becomes 2 times 108. That would, of course, simplify the log 6 to 16. And then you're asking yourself that question in your mind, 6 to the what equals 216? Okay, and we no longer, as of today, need to show our work. We now just simply say that that equals 3. You're welcome to write this work off to the side if you do need it, but as you get comfortable with this, hopefully you can just go straight to the answer there. Okay, you try the next two, pause the video, see if you can get the next ones. Okay, so check your work, see how you did. Just for moving forward, once you've practiced these a little bit, you don't necessarily need that first line that I've been writing. You're welcome to go straight to the second line and then the third line, okay? Just have it there for your examples to make sure that you understand. Okay, so similarly, I hope that you could guess the next one. So the next one, when we are subtracting two logarithms that have the same base, we can write it as a single logarithm with the same base, a, of m divided by n. Okay, and I hope it comes as no surprise that that law is called the quotient law of logarithms. Okay, so let's try it. I think you could probably even take what you learned above, pause the video, and try those next couple on your own. For this first one, we'll write it as a single log of 1024 over 2. Simplify, so we get log 8 to the 512. And then I ask myself 8 to the what equals 512, and the answer is 3. Okay, so check the next two. Okay, check your work. Hopefully that makes sense. Now, for our final law, it's a little bit different, and hopefully, as you could guess, this one is called the power law of logarithms. Okay, so when we have log a of a power, m to the p, for instance, the letters that you use don't matter. This is just to illustrate the idea. That can be written as p times log a m. So we can bring down the exponent in front when it's written as a single power. So this is called the power law of logarithms, like I said, and let's try one of them together. Okay, so the idea here is not to take this power and punch that into your calculator and try to figure that out. Again, the whole concept with these is you shouldn't really need to touch your calculator for most of this, but that's my m to the p, the 25 to the 16, so I can bring down the 16, and then I am simplifying log 5 25, asking myself 5 to the what equals 25, and that's nice and easy, that's 2. And so it's 16 times 2, which is 32. Again, the idea with these laws is you shouldn't really have to pick up your calculator too often here other than to check some numbers, but not to punch in any giant powers. Okay, pause the video, try the next two on your own. Okay, check your work. Now for this one, please make sure that you do not omit any of the steps. You want to be showing all of your steps in terms of simplifying. Okay, so those are the basic laws. Now we're going to go ahead and we're going to sort of look at different ways that questions are worded and try some more examples together. A lot of this, I encourage you to pause the video and try on your own and see if you can interpret it and then check your work. So please be willing and ready to do that. Okay, so in example 1, if you can try most of those questions on your own, that would make sense. In this first question, we're going to use the product law of logarithms. We're going to get log 6, 36, and then I ask myself 6 to what exponent equals 36? It's 2. This one simplifies to log 2, 16, and then that equals 4. That was the quotient law of logarithms. And in this last one, hopefully you can see that it can be written like this using your knowledge of radicals, and then you can apply the power law to bring down the 1/3. And then I'm asking myself here, 3 to what exponent equals 9? And the answer is 2. And thus this one equals 2/3. So sometimes with the fraction ones, it becomes a little more complicated, and thus the laws become that much more important. Okay? So other types of questions that we're going to take a look at. In example 2, it says express as a single logarithm, and then we'll evaluate if possible. So that's a very common question, and the idea there is to use all of your laws to take this expression that we have and write it as a single logarithm, and then evaluate when possible. So in this example, you want to deal with the power law first. So we want to take that 2 log 9 and write it as log 9 squared, or log 81 it will become. And then we can use our product law and our quotient law to simplify it further. You can do this all in one step, or you can do it in a couple steps. So I'll use a couple steps just for you to see. Note they all have the same base, and remember that base, you can't see it, so that means it's a base of 10. Okay, so first I'm going to use my product law, and I'm going to put my 9 squared times my 9. Okay, so that was product law. And then I'm going to use the quotient law. You can simplify at the same time or in the next step. So I'm going to take 9 squared times 9 and divide by 3. That's quotient law. And I'm going to then simplify that and write that as a single logarithm. So 81 times 9 divided by 3 is 243. Remember, there's an imaginary base 10 there. And so then when I say evaluate if possible, whether it's exact or you need to pick up your calculator in this case, because 10 to the what equals 243, it's not a nice number. So you just pick up your calculator. That's why this one is base 10, because then you can punch it in, and I get 2.39. Okay, so pay attention to what the words are of that question. We're going to come back to that in a minute. In terms of steps that you need to show most of this work. However, you could do your product law and your quotient law all in one step. Okay? Let's try and see if we can then go the other direction. So this next question asks us to express as a sum or difference of logs. So it's basically like take this single log now and expand. So take log 2x squared yz to the 4 and go backwards compared to what we were just doing. Okay, so pause the video, see if you can take a guess on your own, and then come back and check out your work. So working backwards, I'm going to do the opposite of before. First, I'm going to break it up into addition and subtraction. So using the product law and or the quotient law. In this case, it's all multiplication. So it's actually all product law, right? Like that. So I can write this as log 2x squared plus log 2y plus log 2z to the 4. I was using the product law there. And then we could take it one step further, again, sort of working backwards from what we did before, and we can apply the power law. So this can be written as log 2 log 2x, nothing to be done with the middle one, and then 4 log 2z. So that's us using the power law. And that's what we mean in a question like that. So you're going to practice some of those. Okay, so using what we just discussed, okay, here's example 4. I want you to try the first one. So you're going to write it as a single logarithm, so similar to example 2, and just pause when you pause the video and then come back when you think you're done. Okay, so just like we did in example 2, we're going to do the power law first. And bring up those exponents, and then hopefully you can see that it's addition, and so I'm going to use my product law. They both have the same base. It's imaginary. It's 10. So putting those together, I would have x to the 4, x minus 1 squared. Okay, so that is a single logarithm, right? Log of one thing. Okay, sure, we could expand here in the brackets, but it really doesn't serve us any purpose, so that's all we're doing there is writing as a single logarithm. And obviously there's no evaluating here because we have polynomials there. Okay, so using a similar idea, pause the video, try B all by yourself. Okay, so there I used the quotient law to start off. Now, in this one, it does have sort of a purpose to factor in this case. Same rule for expanding. If it has a purpose, then you should do it. But here, notice when I do factor the top, then it actually simplifies to a more simple single logarithm, right? Because then I can cancel out my x plus 2's. And so the single log is log little 3 or base 3 of x minus 2, and that's nice and simple. So you don't factor or expand unless it serves a purpose. But if it does serve a purpose, if it simplifies more, then you do want to make sure you're doing that. Okay, and there's the practice work that you're going to do from the textbook. Thanks.